We're going to continue with dividing. We're going to be looking at D, E, and F. When we're looking at this, remember that what we're going to be doing is we're going to take this division and we're going to make it multiplication. And how we do that is we flip the second terms, just like what we did in junior high when we were looking at basic fractions. So when we rewrite this, what we're going to do is we're going to rewrite it as multiplication. So x to the 7th and y. We have x to the 5th, and we have y to the 3rd. We change it to multiplication by multiplying by the reciprocal. So now what we have is x to the 3rd, y to the 5th on top, and on the bottom we have x to the 2nd, y to the 6th. Now what we're going to do is we're going to multiply across. So when we multiply across, remember we're adding the exponents. 7 plus 3 is 10. We have 1 and 5. That would be y to the 6th. We have 5 and 2. That would be 7. And we have 3 and 6. That right there would be 9. Now what we have to do is we have to look at the x's and see, are there more x's on top or on the bottom? When we're looking at this, notice that 10, 7, so there's more x's on the top, and that would be 3 more. 6, 9, that means that there's more y's on the bottom, that would be 3 more. So that right there would be our first answer. Remember, with our second answer, we're looking for excluded values. We talked about this earlier. We have monomials. Whenever it's monomials, it's always 0. But with this problem, we have an x and we have a y, because in the problem, there's an x and there's a y. So our excluded values have both of them. Now, looking at the next one. Remember, first step with division is flipping it. We keep the first one the same. And we're changing it to multiplication. And why we're able to change it to multiplication is because we're multiplying by the reciprocal. Now, when we're looking at this, what we notice is that the x plus 5s can cancel. We see that 14 and 21 both have a 7 in common, so that becomes a 2 and a 3. We see that the x squared can cancel with x to the 4th. And so what we're left with is a 2. We have a 3 on the bottom. We have 2 x's right here. And we have the x minus 3. That right there is our first answer. Our second answer is looking at our excluded values. Now, if you remember last time, division is a little bit more difficult with excluded values, because not only are we looking at our denominator, which would be 0, 3, and -5, but we have to look at the denominator of the beginning. Thankfully, that's going to be exactly the same as the last one. So we could put 2 zeros, but since we already wrote it once, no need to write it again. Now, looking at letter F, what we're going to be doing is we're going to be doing the same thing that we always do with division, is we're going to multiply it by the reciprocal. So we have 9, we have x plus 4, we have x plus 6, we have 12, we have x plus 3, we have x minus 6. Changing it to multiplication, we have 2, we have x plus 4, we have x minus 5. We have 15. We have x minus 5. We have x plus 3. Now for the fun part. We're going to look to see what we can cancel. When we're looking at this, we see an x minus 5 cancels. Let's see if we see anything else. This is a little tricky because when we're looking at it, notice that this is a plus 6. This is a minus 6. Obviously, those can't cancel. The 4s look like they could cancel, but they're on the same side, so we cannot cancel them. The 3s are also on the same side, so we cannot cancel those. But 9 and 12 can reduce to 3 and 4. And 4 and 2 can cancel. And 15 can cancel with 3. So now when we multiply across, 1 and 1 gives us 1. We have an x plus 4 and another x plus 4. So I'm going to put x plus 4 squared. Plus I have that x plus 6. In the denominator, I have a 2. I have a 5. That gives me a 10. I have an x plus 3 and another x plus 3. So that gives me x plus 3 squared. And I have an x minus 6 right here. It doesn't look much more simplified, but that is our answer. Now, we're looking at our excluded values. Excluded values is what gives us 0 in our denominator. And when we're looking at this, we know that we have a negative 3. We have a negative 3 twice. And we have a 6. And we have a 5. We have the 6. We have the 5. These don't have x's, so we're not going to put a 0. But remember, we have to look at our original, and our original has a negative 4 that would give us 0. This right here would be negative 4, and that's a 5. Since we already have 5, no need to put it twice. And that right there is our answer.